Hello student, this is the third part of transformation of axis concept. Part 1, part 2 completed. Part 1 introduction. In part 2 I started transformation of axis, that is called translation of axis. Translation of axis. Just shifting origin one place to another place without changing the direction of coordinate axis. Such transformation is called translation. Now today's concept is second type of transformation called rotation of axis. What will do in rotation? In rotation, without changing the position of the origin, will change the direction of coordinate axis. Okay, just for example, this is the black color one is x-axis and this is y-axis. Now this becomes new x-axis and this becomes new y-axis. What I did for new system, this only the center origin. For old system also this only the origin. Origin is same, but what the difference means that the direction of coordinate axis are changed. Okay, this is new x-axis, the new y-axis. Assume that the angle between these two, new x-axis and new x-axis and old x-axis theta, automatically angle between new y-axis and old y-axis should be theta. Okay, so such a way that axes are rotated. This type of transformation is called rotation of axis. Okay, if axes are rotated through an angle of theta about origin without changing the position of origin, then the transformation is called rotation of axis. Okay students, for example, p small x comma small y are the coordinates of p with respect to old axis. Automatically coordinates of p will change with respect to new axis. How to find the coordinates of p with respect to new axis? That is first thing. Next thing, for example, this is the y equal f of x comma y equal to 0 is the equation of this curve with respect to old axis. If axes are rotated through an angle, automatically equation of the curve will change. What happened to the equation of the curve? These all things should we learn in this class. Okay. So okay, so now once again listen student, if the axes are rotated through an angle of theta, either at clockwise direction or anti-clockwise direction, that is not mentioned, no? Whatever may be, it may be clockwise or anti-clockwise about the origin without changing the position of the origin, then the transformation is called a rotation of axis. Okay, students listen here, important theorem, difficult theorem. So for all this proof is not important, the result is important, but I want to explain the proof also. Yeah, theorem number C3 I can say, if the coordinates x comma y of a point are transformed to capital X comma capital Y when the axes are rotated through an angle of theta about the origin, then small x equal to capital X cos theta minus capital Y sin theta, at small y equal to capital X sin theta plus capital Y cos theta. So in previous result in translation of axis, you observe that yeah okay, the relation between capital X and capital Y and h and k, like that here the relation between capital X and small x and theta, there h comma k, here theta. Okay, how to establish result, that is important thing. Listen all of you. So I want to draw diagram for this. This is old y axis, this is old x axis. I will write x axis old, this is y axis, or I can say original, that is better word. Now and this is new x axis, sorry, no, this is new x axis and this is new y axis. Okay, what I should write here? New y-axis, NV I will write, NX I will write, new x-axis. So angle between them is theta, means amount of rotation is theta. Assume that in anti-clockwise direction, either clock or anti-clock, that is not important. Okay, for example, this is the point P, whose coordinates are small x comma small y with reference to old axis. Okay, I will write, let P equal to small x comma small y with respect to original axis. axes plural. Let I will use another color for that. P equal to capital X comma capital Y with respect to new axis. Okay students, listen. So important thing is, from here if we draw perpendicular on new old x-axis, length of this line segment is mod x1, sorry, mod y1. So draw perpendicular here, this length is nothing but mod x1. This is mod y1, this is mod x1. Okay, for example, draw perpendicular on new x-axis, this is mod y1 capital Y1, mod capital Y1, sorry, mod capital Y, because capital X comma capital Y, no, with reference to new axis, this becomes capital Y and this becomes capital X. Okay, so this becomes what, nana, small y, this becomes capital Y, this becomes what, small x, this becomes capital X. Using that concept I want complete. Okay students, so constructions are required here. From P, draw perpendicular on old x-axis, perpendicular on old y-axis. Listen all of you, I want name it as A, this one as B. I will write here PA equal to OB equal to what, na, that is Y, comma PB equal to AO or OA equal to X. Leave it. Next, from here we need to draw perpendicular on this. Okay students, listen now. Here perpendicular. Yeah, A, B completed. Let it is C and this is a D. What happened? I will write here PC equal to OD equal to capital Y, comma PD equal to OC equal to capital X. I am not using modulation. I assume that P is in first quadrant. Okay. Next, let already this angle is theta, no? Which one? AOC. Yeah. Let angle AOC is theta. Then, student, interesting thing. So this is theta, this is 90, no? What is this? 90 minus theta. This is 90 minus theta. This is 90. What happened to this? This is also theta. Okay. So then what happened? Angle CPA. Angle CPA. Also theta. This is interesting step. So next one is, from C, draw perpendicular on this. Name A, B, C, D completed. Let it be E. Already a theta. I will write in next page. From triangle, so what I should do, this is say some F. From triangle AOAF, that is not correct. Again you need to draw another perpendicular here. I will write draw C, F complete, A, B, C, D, F, G, CG perpendicular to x-axis. X-axis is old x-axis here. CG. So first of all I will take the triangle, this triangle, this total triangle I will take. What is the name? OGC. I will write in separately. From triangle OGC, I will find sin theta and cos theta separately. Sin theta means CG by OC. CG by OC. CG as it is, Okay, OC means what, Nana? OC means what? Somewhere I wrote, no, OC here. OC means capital X. Here, capital X. What capital X I can write? Or CG equal to capital X sin theta. So this is one of the important results for us. Yeah, from the triangle only try to find the value of cos theta. Cos theta equal to OG by OC. That is equal to OG by X. Or OG is equal to X cos theta. This is also another important interesting result. Yeah, take next this triangle, Anna, this triangle, this one. What is PEC triangle? From triangle PEC, find sin theta and cos theta. Sin theta equal to CE by PC. Already somewhere I wrote PC equal to what, Nana? Actually PC equal to somewhere here. PC. Actually PC should be small y. PC, PA I wrote, why I wrote PA? Okay, PA correct only. PC means, yeah, PC here, see, capital Y. This is CE by capital Y. Or CE is equal to capital Y sin theta. Yeah, one of the important result. Next, find cos theta, Nana. There, cos theta. From the triangle, I will show you. Cos theta is equal to PE by PC. PE by PC. So PE as it is, you write. Don't disturb. PC means what, capital Y I can write. What is the meaning of that? PE is equal to Y cos theta. Yeah. Now actually we want to create the relationship between small x, small y, capital X, capital Y and theta. Okay, students. So next page I will write what is small x here. Small x means what? I will show you. Small x, where is that? PB, no? Small x means PB, or that is OA. PB, I will write PB equal to OA equal to PB equal to OA. Students, listen. What is OA, Nana? OA means OG minus AG. OG minus AG. Okay, observe from diagram. OG, you don't disturb that. Instead of AG I can write EC, I can write rectangle, no? EC I can write. OG minus EC. Now I want substitute. Somewhere I got OG. Where is OG? Yeah, OG, see here, OG. What is OG? X, capital X cos theta. Capital X cos theta. Somewhere EC I got, somewhere EC. You go CE, capital Y sin theta. What is this? Not small x. Now what I got? Small x equal to capital X cos theta minus capital Y sin theta. This is the relationship between capital X and capital Y and small x and cos theta. Like the remaining results, small y also you want, small y value. Okay, interesting result, Anna. Interesting topic and difficult topic. So small y I want, I will show you where is that small y. Small y means what, Nana? PA only, PA or OB. PA equal to OB. Now OB means what here? OB, where the diagram? OB. Yeah, OB. OB is nothing but PA. PA is better than OB. I will erase it. PA only I will take, Nana. Okay, now PA equal to, see here, PA means what now? PE plus EA. PE plus plus EA. Okay, next, instead of PE, something you can write already proved somewhere. It's here PE. What is that? Capital Y cos theta. Capital Y cos theta. I will write capital Y cos theta. So instead of EA, what should write? I will show you EA. EA. Where is that? EA means CG only. EA and CG are same. Since EA is equal to CG. Now Y cos theta plus CG. Where is CG? Somewhere I proved CG. CG. Capital X sin theta. Capital X sin theta. So this is the value of Y nana. So I want to write in order. Y equal to capital X sin theta plus capital Y cos theta. So in this way you can find x and small x and small y values in terms of capital X and capital Y and theta. But how to remember? There is very difficult one here. How to remember result? Listen all of you. What happened here? If the coordinates of small x comma small y of a point are transformed to capital X comma capital Y when the axes are rotated through an angle of theta about the origin, then the relation between those two, small x, what you got? Small x equal to capital X cos theta. See, capital X cos theta minus y sin theta. See here. Small y equal to capital X sin theta plus y cos theta. But how to remember? They are very difficult, no? How to remember this? So have a tool to remember this. We have a table. By using the table, you can remember easily. That's not big problem. Okay. So listen. This is the table. The transformation of coordinate axes when the axes are rotated to the angle theta can be obtained from the following transformation table directly. For example, you want small x and small y, students. You want small x. I want to give arrow like this. And small y you want. So how to write small x? I will write here. So how to working rule for this? Small x equal to capital X cos theta plus capital Y into minus sin theta, directly minus capital Y sin theta. You want small y equal to capital X sin theta plus capital Y cos theta. See here, that only you got previously. See, that only you got. Sometimes you want capital X and capital Y, nana. Sometimes you want capital X and capital Y. If you want capital X, arrow like this, arrow. I will write that also. Sometimes you want capital X equal to small x cos theta plus small y sin theta. Small x cos theta plus small y sin theta. Sometimes you want capital Y in terms of small x and small y and theta. Capital Y equal to minus x sin theta plus y cos theta. Okay, student, no need to remember these four. Just try to remember this table. Here capital X, capital Y. Here small x, small y. Here theta. Cos minus sin theta. That's enough to remember one column. One row. Cos theta minus sin. That's all. Automatically this becomes sin theta, cos theta. Cos theta minus sin theta. How to remember? I will show you here. So just write box in examination. Listen, students. Yeah, this is capital X, capital Y. This is small x, small y, theta. Cos theta minus sin theta. Enough. Cos after sin theta, and this is cos theta. Now you know how to operate it. So by using this table only, you can complete the problems. That's why this table is very, very, very important for us. I can say important for us. Everyone should remember this table. By using this table, you can make small x and small y as subjects, or capital X and capital Y as subjects. How you got this table is just now I explained the concept. Using this concept, you will get the results. Okay. Now I will explain this through one example problem, students. Write the new coordinates of the following point 0, 5 when the axes are rotated through an angle of 30 degree. Old point, this one, old point. We want for new point. I will write coordinates of P, that is equal small x comma small y, that is equal to 0, 5. What should find? Coordinates of new capital X, capital Y you want. Okay, theta is given as 30 degree, clearly given positive angle. So capital X, capital Y you want means what should do? You want to use this result. Capital X equal to something. But in examination, how to write? So just to do one thing, Nana. Sorry. Try to draw a table in examination. Then we'll get idea. See. Okay. So here small x, sorry. Here small x, here small y, here capital X, here capital Y. What I told, cos theta minus sin theta. Okay, see, cos theta minus sin theta. Should remember now. After that, here sin theta, cos theta. What is theta here? 30 degree. I will write that values only. Okay, no problem. What I want? Capital X I want. Capital X equal to, observe here, capital X equal to small x cos theta, small x cos 30 degree plus small y sin 30 degree. Okay, capital Y equal to, see here, capital Y equal to minus small x into sin 30 degree plus, yeah, y into cos 30 degree. Now we need to simplify this. So capital X equal to, yeah, x into root 3 by 2. Yeah, plus y into 1 by 2. Okay, so capital X equal, already x is given as 0, no? 0. 0 into root 3 by 2. Plus y means what? And 5 into root 3 by 2, 5 by 2. So finally, capital X I got 5 by 2. No, capital Y I want. Capital Y equal to x means 0 into sin 30, 1 by 2. Plus y means 5, that is root 3 by 2. So capital Y, what you got, Nana? 5 root 3 by 2. Therefore, new point is equal, or transformed point equal to 5 by 2 comma 5 root 3 by 2. This is the answer for the problem. Okay. Example 2. If the coordinates of P are transformed to 2 comma minus 4 root 3, when the axes are rotated through an angle of 60 degree, find P means new P, old P you should find. This is given new P, Nana. New P given, new coordinates given. These are the new coordinates. See, the coordinates of P are transformed to. Transformed to means changed one. So, coordinates of new coordinates of P, that is called capital X and capital Y, equal to 2 comma minus 4 root 3. We want to find small x and small y. Theta is given 60 degree. Yeah, students, draw the rough diagram. Every time you need to draw a diagram, then only you get, you can remember the table. Otherwise you can't. This is this is theta, small x, small y, capital X, capital Y, cos theta minus sin theta. This is sin theta, cos theta. Completed. What do you want? You want small x you want. Small x, I will write small x equal to, how to operate like this, arrows. For capital Y, arrows. Small x equal to, what? Capital X cos theta minus capital Y sin theta. So capital X means what? 2. Theta means 60 degree, cos 60 degree. Minus y means minus of minus 4 root 3 into sin 60 degree. So 2 into 1 by 2 plus 4 root 3 into root 3 by 2. Okay, 1 plus here 2, 6, that is equal to 7. So what you got? Small x equal 7. Next small y you want. Small y equal to, see students, capital X sin theta nana plus capital Y cos theta. So what is capital X here? 2. Theta means sin 30 degree, sin 60 degree, minus 4 root 3 because y is here minus into cos 60 degree. That is 2 into root 3 by 2. Okay, minus 4 root 3 into 1 by 2. That is called root 3 minus 2 root 3. That is called minus root 3. What I can say? Old point, original point equal to 7 comma minus root 3. Okay. Yeah, next question. Find the transformed equation of 17x square minus 16xy plus 17y square equal 225 when the axes are rotated through an angle of 45 degree. We want for transformed equation. Instead of small x, what should write? Instead of small y, what should write? First of all, you need to identify that. Okay. So here theta equal to 45 degree. First of all, you need to prepare the table for every time. Okay, students, listen. Small x, small y, capital X, capital Y, cos theta minus sin theta. Okay, sin theta, cos theta. Small x value you want. First, find the value of that small x. Small x equal to capital X cos theta minus capital Y sin theta. That is equal to capital X into theta 45 cos 45 minus y into sin 45. That is capital X minus capital Y by root 3 because root 2. Cos 45 1 by root 2 and sin 45 also 1 by root 2, 1 by root 2 taking LCM. Small y I want now, small y I want. Small y means what? Capital X sin theta plus capital Y cos theta. Directly what will get Nana? Sorry. Yeah, capital X capital Y by root 2. No, transformed equation of that should write. Transformed equation of what? 17x square minus 16xy plus 17y square equal to 225 is here. 17 as it is. Instead of small x, what should write? Capital X minus capital Y by root 2 whole square minus 16 into capital X capital Y by root 2 into capital X plus capital Y by root 2. Yeah, plus 17 into capital X plus capital Y by root 2 whole square equal to 225. So here only I want to simplify. Okay, students, listen, here square is there. Okay, 70 here also square is there. 17 into capital X minus capital Y whole square by 2 root of 2 minus 16 into capital X minus capital Y into capital X capital Y by 2 plus 17 into capital X plus capital Y square by 2. Transfer the 2 into 225. Okay, so 17x square plus 17y square minus 34 capital X capital Y minus 16 times of capital X square minus capital Y square, 16 times of capital X square plus 16 times of capital Y square plus 17 capital X square plus 17 capital Y square plus 34 into capital X capital Y is equal to, that is 50, 450. Now we want to simplify. Yeah, some cancellations, I think these two will cancel. Students, listen. 17x square minus 16x square, another 17x square. So 34, 33x square. Na? Anything wrong? Here 117x square, here minus, here plus, correct only. This is plus x square, 18x square. Okay. This plus 17y square plus 17, 34. 34, this x, no, okay. 17 plus 17, 34, 34 plus 16, 0, 3, 50 plus 50 y square is equal to 450. 50. We can divide throughout by 2, then 9 capital X square plus 25 capital Y square equal to 225. So now final conclusion, therefore transformed equation is, what 9 capital X square plus 25 capital Y square equal to 225.